Hello class, this is it's Dr. Frank Amankuna again. In this video, we'll be talking about sampling distributions and estimators. There are certain estimators that are biased or non-biased. So for this week, this is the first video. This is objectives. At the end of this, you should be able to understand the concept of sample distribution of a statistic, sample proportions, sample mean, median, sample variance, sample standard deviation, and the range. Now remember, statistics in this case is a number. It could be the average or any of these that I mentioned. And also determine whether an estimator, okay, since generally we don't know the value of the population parameters, we use some values to estimate it. And those could be biased or unbiased, and we will know what they mean by biased and unbiased estimators. Okay, so let's define a sample distribution of a statistic. Okay, it is, as is indicated, is a sample proportion, or example, is a sample proportion or a sample mean. So this is a distribution of all values of the statistic. So if you're talking about the mean or the range or median, when all possible samples of the same size n are taken from the same population. Okay, the sample distribution of a statistic is typically represented as a probability distribution. Remember, probability distribution that we talked about in the previous section, chapter 5. Okay, probability distribution, we talked about this in chapter 5. So take note of that. Now, let's go to the next one. So what is an estimator of a statistic, or estimator it is a statistic used to infer or estimate the value of a population parameter, as I said earlier on. Okay. So then what is an unbiased estimator? It's a statistic that targets the value of the corresponding population parameter, in the sense that the sampling distribution of the statistic has a mean that is equal to corresponding population parameter. So for example, if I find the sample mean, and I take the mean of that sample mean, and if I calculate that and it's the same as the population mean, then we will say that the sample mean, X bar, is an unbiased estimator. And what we mean by that is that it targets it gives the same value as the population mean. So these are the following are unbiased estimators. So in this presentation, I'm going to give examples, particularly for the proportions, so the sample proportions, that's p hat, and then sample mean X bar, and then variance, sample variance. Okay, so these are unbiased estimators. Then the biased estimators are the median, the range, and then standard deviation. Okay, so if I may summarize that quickly, we say that a biased estimator does not target its corresponding parameter. Examples are median, range, and standard deviation. And then the unbiased estimators are the sample proportions, that's p hat, the sample mean H bar, and then sample variance S squared. Okay, so we're going to take example, and I'm going to use this example a lot. I'm going to use this example to determine whether an estimator is biased or not. Okay, So I want you to pay attention to this particular example because we'll be seeing it often. It said a friend of the author has 3 children with ages 4, 5, and 9. So let's consider the population. So note that our population is a set of what? The children of ages 4, 5, and 9. And it said if 2 ages, that is, if 2 children of the ages, which we call a sample size n is equal to 2, are randomly selected with replacement from the population, okay, then what will be the following? Okay, the question is, what is the list of 4 different possible samples along with the word probabilities? Okay, so now remember our population, okay, the population is a set with what values 4, 5, and 9. Okay, so since we have sample size, my n is 2, and then it says that without what replacement. So it means that if I'm selecting 2, I have these ages, I've tagged this 4, 5, and 6 and put it in the bag. I can pick 4. Before I pick the second one, I drop it and then pick again. So I can pick 4 and 4 for the 2 sample. I can pick 4 and 5 and so on. So what are the possible samples for this particular one, this population? Well, I'm gonna have this and then write the probabilities. So write the samples here. Okay, so I'm going to write my sample. I can have 4 and 4. I can have 4 and 5. I can have 4 and 9. Or I can have 5 and 4. That is my first one. I select this one, 8, 5, the child with 8, 5. I can have 5 and 5. And then 5 and 9. Or we can have 9 and 4. 9 and 5. 9 and what? And 9. Okay. So if we have this, then what is our, just remember we finding the what? The range, okay? So we'll call this sample range, okay? Now what's the range? Range is what? The highest minus the lowest. So if you have subtract 4, okay, 4 minus 4, the range is what? 0. If I take the next one, the range is what? 5 minus 1. So 5 minus 4 is what? Is 1, okay? That is 5 minus 4 is 1. Then I do 9 minus 4 is what? 5. 5 minus 4 is also 1. 5 minus 5 is 0. 9 minus 5 is 4. 9 minus 4 is 5. 9 minus 5 is 4. And then 9 minus 9 is what? 0. So these are my possible, this is my sample, okay? These are my samples, and this is my possible samples, and I'm finding a range for each of the sample of size of size 2. Okay, so then I can write my probability distribution as we learned in chapter 5. Okay, the probability distribution. Okay, let me think I have the, all right. So we're going to write this. If I have this, that will get to my second part. So this is the list of all the possibles with their probabilities. Well, what is their probability? Say that along with what? Their probability. That's what we want to do. So then if I do this, what is the probability of that? Okay, let's find that before we go to the part B. What's the probability? It means that how many samples we have. I have 9 of them. I go 1, 2, 3, up to 9. Now, how many of them have the range of 0? So I have 0 is what? 2 and 3. So that is what? 3 out of what? 9. That's the probability. Now for the 1, we have 1, 2. So that is 2 out of 9. And then we have what? 4. Sorry. Let me take this back. I want to define the individual and then I'll summarize them in the next part B. Okay. So let us go back. Okay, 0 is 1 out of 9, so that's 1/9. 1 is also 1 out of this 9 over here, so that is what? Also 1/9. 5 is 1/9. 1 is also 1 out of 9. 0 is 1 out of 9. 4 is 1 out of 9. 5 is 1 out of 4 out of 9. 4 is 1 out of 9, and then 0 is also 1 out of 4 out of 9. 1 out of 4 out of 9. So we have 1, 2, 3, 4, 5, 6, 7, 8. Now, if you add these probabilities, okay, you get 1. Now that takes me to the next part B. Okay, it said describe the sampling distribution of the sample mean, okay, and in a summarized table. So what we did over the previous year, we're going to summarize this. Now what we're going to look at is that if I look at the sample range, what are the possible values? We have 0, we have 1, we have 4, 4 and 5. These are the possible values of the range, and then we'll put the probabilities together. Okay, so here is my table that describes that. Okay, this is the sample what? That's a sample range. Okay, and then have the what? The probabilities. So we have 0, 1, 4, and 5. Okay, now the probability of how many 0? We had 3 of them. So we get what? 3 out of 9. Okay, let me show you back. Because if you look at how many zeros we have 4. We have 1, we got 2, and 3 out of the 9. That's why I got 3 9s. Okay, so for 1, we have there are 2 of them. So that's 2 out of 9. 4 is 2 out of 9. And then 5 is also 2 out of 9. Okay, so if we add everything, we get what? 6, and then 9 again, 9 out of 9, which is what? 1. And this describes what? The probability distribution. As we learn in chapter 5, the probability distribution, it has what? The random variable. In this case, we're going to use X for that, for this part. Okay, you can put it as the random sample or random variable X has distinct what values? 0, 1, 2, 3. And each probability of any random variable is what? Between 0 and 1. And then the sum of the probabilities is also 1. So you see that represents what? The probability distribution. So the question is that we want to find what is the mean, okay? What is the mean of the sample range? Now, how do you find the mean of a probability distribution? This is what the expected what? The expected value of the random variable, in this case X. And how do you calculate that? So we denote it by what? E of X, and that is equal to the X times its probability. So 0 times 3 out of 9 plus then 1 times 2 out of 9 plus 4 times 2 out of 9 plus 5 times 2 out of 9. Now this gives me 0 plus 2 out of 9 plus 8 out of 9 plus 10 out of 9. And that gives me 20 out of what? 9. And divide by the 2.2 to what? 1 decimal place. Okay, so this is the mean, remember? Mean of the what? Sample range. So mean of the sample range is given by what? This. Okay, so now it says that the next part is we'll calculate the population what range. Okay, what's our population? Our population is what? Is a set of has what? The numbers 4. The children have the ages, there are 3 children, ages 4, 5, and the what? And 9. So what is the range? So the population range In this case, it's going to be 9 minus what? 4. That is a maximum minus min. And this is equal to what? 5. Okay. So is it based on the results? Do the sample ranges target the population? Okay, what's the answer to this? The answer is what? No, because the mean of the sample range is not equal to what? The population range. Because we got this to be 2.2. Of course, 2.2 is not equal to what? 5, which is from here. So then what can we conclude? What do these results indicate about the sample range as an estimator of the population? Okay, now since the mean or the sample since the mean since the mean or the sample range, the mean of the sample range, in this case, does not target the population range, the sample range is what? A biased what? A biased estimator. Okay, biased estimator. Okay, so take note of that. Okay, now here's another example, another statistic. That is the proportions. So if I have a sample of size n and I find the proportions p hat for each of the samples. So if you get p hat 1, p hat 2, and you take the mean of this p hat, the p hats, okay, you can see that is what? Normally distributed. Now, if it's normally distributed, it means that it's going to target the what? See, the mean will be the same as what? The population mean. But what's going to happen is that you see that the mean, the population of the mean of that will be equal to the population proportion. Okay, so we just said that the sample proportion is a what? Unbiased or estimator. So we're going to use an example to illustrate this. Okay, but before that, when you say it's an unbiased estimate, what do we mean? When samples of the same size are taken from the same population, the following two properties apply. Sample proportions tend to be normally distributed from the diagram that we just talked about. 2, the mean of the sample proportions is the same as the population mean. What means that it is what? It targets the what? The population what? Proportion. Therefore, it is what? Unbiased, as I mentioned. Okay, so let's take an example. Here is an example. Say that a hybridization experiment begins with 2 peas having yellow pods. We're going to denote that by what? Y. So if it's 2, we're going to have what? It's going to be Y. We're going to have Y1 and then Y2, because that's we have a 2. The 2 peas that are what? That have what? Yellow pods. And then 1 what? P having what? Green pod. We want to denote that by what? A G. So if 2 of the P's are randomly selected with replacement from this population, they say use a table to illustrate okay, of the P's to find a sampling what distribution. Okay, so part A, all right, since this you have two yellow, two are yellow pods, and then one is what green. Okay. So what would be my distribution or possible probabilities? So I could have y1 and y1 because I can have, because I'm selecting two samples with replacement. Or we can have y1 and y2. That is the second yellow pod, the P with the yellow pod. Or we can have y1 and then what? The one with the green. Or we can have y2, y1, y2, y2, or we can have y2 and then the green. Okay, or we can have what? Green and y1, green and y2, and green, green. So if I put this together, right, with their probabilities, this is my sample. Okay, so the samples are, we have y1, 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 y2, y1, green, y2, y1, and then y2, 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 green. They have green, y1, green, y2, and green, green. So we want to find, these are the proportions. We want to find the what? The sample proportions. Okay, I want to call it, say, P. I want to call it like X, or let's call that sample proportions. Okay, we are talking about proportion. Okay, proportion with what? With yellow pods. So take note of that. Proportions with yellow pod. So here we have two of them. They are what? So what's the proportion? That is, what's the fraction of that? It's going to be the two yellow pods out of two. So this is equal to 1. Okay, that's for that. The second one also do what? 2 out of 2, which is 1. But here you have what? 1 yellow, 1 green. So the proportion of yellow MEPs with yellow pods will be what? 1/2. Okay, which is the same as 0.5. The second one, the next one will be also 1 because we have 2 over 2. The next is also 1. The next will be what? 1/2. The next will be 1/2. Green and yellow, 1/2. And then there's no what? There's no, yeah, because they are both what? They are both green. Okay, so we can summarize this. Okay, and if you want to put the probabilities together, let me erase this part, and then I can put a probability distribution right here for you to see. Okay, so we have the possible values, okay, of the sample proportions. Sample proportion with the yellow pods, okay. From this part, okay, what are the values? It could be 0, it could be 0.5, or it could be 1. Okay, this is 0.5. So, and this is the probabilities. So for 0, how many we have there? There's 1 out of how many? There were 9 of them. 1, 2, 3, 4, 5, up to 9. So that is 1/9. Okay, for the halves, how many are there? There are 4 of them. Okay, we have 1, 2, 3, and then 4, 5. So that's 4 out of what? Out of 9. And then for 1, we have also what? 4 out of 9. Now, if you see that, if you add this together, you have the sum of what? All the probabilities. This case will be what? Will be 1. Okay. So this is the table that describe the sample distribution of what? The proportions of the p's with the yellow points. Okay. So now we want to find the mean of that. Just like we did before, we're going to find the expected value of what? Using this table, because this is a probability distribution, right? So let's find the expected value of that. So part B, it's a calculate the mean of the sample distribution and population proportion of the p's with what? Yellow points. Okay. So that will be the expected value. Expected value of what? Of the proportions. Okay. Which in this case will be what? So if you go back to the table, it will be 0 times what is probability, 0.5 times is probability, 1 times is probability, and then we find the what? Okay. So we have what? This is going to be the 0, okay, times its probability is what? 1/9 plus 1 times its probability is 4/9 plus that is so the other one is 0.5, okay, times its probability is what? 4/9. Okay, this is equal to 0 plus 1/4, sorry, 4/9, sorry, 4/9, then plus what? 2/9. This gives me 6/9, and we should simplify it, get what? 2 out of what? Out of 3. So what is the population what? This is this mean of what? The sample proportion of the p's with what? Yellow points. Okay. Now we got what? 2.5. Now our population is what? Remember, we have what? 2 yellow pots. That is 1 and another 1. And then we have 4 green. There are 3 in total. So what is the population proportion? Population proportion, which we denote by P. Okay, 2 out of 3. That is also 2/3. Now note these values. See that they are equal. Hence, the question part C, the answer to questions part C will be what? Is the mean of the sample proportions equal to what? The population proportions of p's with what? Yellow points. The answer is what? Answer is what? Yes. Okay, it is yes. Now, so is the sample proportion P an unbiased estimator? Yes. So this P hat is what? An unbiased estimator of the population proportion, which is what? Which is P. Okay. Now, this example, but I'll do that in class this week. So come to class to see that. That's a homework. 6.3, question number 2. We'll do that together. So in the summary, what we've done is that we find the proportions. Okay. Here we find the proportions, and then we found the sample of what? The proportion of the p's with the yellow pots, and we find the probability distribution. And then what's the mean of that is the expected value. So 0 times the corresponding probability. So the x of what we call it, the random variable times its probability to give us that. Okay. Now, here's another example. remember we said that median is also a bias estimator. So I'm going to use the same example. If you remember, a friend of the author has 3 children with ages. So I told you that you have to remember this will come back again. So this time we don't want to find the what the range. We want to find the median. Okay, there's 2 sample size is the same. Okay, sample size is the same. So the samples will be the same as what we did in what the previous example to find the range. Okay, so it's a use a table to describe that, and then the question is that do the values of the sample median target the value of the population median? If so, what can you conclude? Now, what we are looking for is that if it targets, then when we find the mean of the sample median, it must be the same as finding the median of these numbers. Now, what's the median? Median is a middle number. Okay, so if I have 2 numbers, 4 and 5, what's the median? Will be the average of the 2, which is 4.5. Good. So now let us find the same samples that we had before. Okay, the same samples, and then I will give the probabilities. So here is our samples. Okay, we have 4 and 4, 4, 5, 4 and 9, 5, 4, 5, 4, 5, 5. That is selecting 5 and select 5 again. 5, 9. And we have 9, 4, 9, 5, and then 9, 9. Okay, so then we want to find a median, sample median. Sample median. So what's the median of 4 and 4? It is 4. What's the median of 4 and 5? That is, take the average of that, that's 4.5. The median of 4 and 9, okay, 13, that's what? 6.5. And then for the next one, it's what? 4.5. Do I have the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, I think I have this double. Cancel one of them. And then 5, 5 is what? Is 5. And then 5, 9. Okay, 5, 9 is 7. That's 14 divided by 2. And then 13 divided by 2 is what? 6.5. And then we have 14 divided by 2, that's 7. And 9 plus 9 divided by 2 is what? It's also 9. Okay, so what is the distribution? Okay, so let's get another table. That's my probability distribution. Probability distribution in this case, okay, I have my what? Sample median. The sample median has these numbers, as you can see from here. Okay, we can have what? 4. We have what? 4.5. We have 5. We have 6.5. We have 7, and then 9. So what is the probabilities of these guys? Okay, for 4, the total sample is what? 9. The 9 of them. So for how many? Just 1 out of 9. So that is 1 over what? 9. 4.5, we have 2 of them. Okay, which is what? 2 out of 9. 5, we have 1. So that's 1 out of 9. 2.5, we have 2 of them. So that is what? 2 out of 9. 7, we have 2. That's also 2 out of 9. And then 9, we have just 1 out of 9. Okay, so now to answer this question, I got my probability what? Probability distribution. This is here. So I'm going to find the what? I'm going to find the population median and also find the what? Mean of the sample median. Okay. So mean of the sample median. Okay, so first let's find the mean of the sample median, which is in this case the expected value. So each of the random variable times its probability. Okay, so I'll have for 4 times the probability is what? 1/9, as from the previous table. Okay, then plus I have 4.5. Its probability is what? 2/9. Then I have 5. Its probability is what? 1/9. Then plus I have 6.5. Its probability is what? 2/9. I got 7. Its probability is what? 2/9 plus 9, and its probability is what? 1/9. Okay, so if you simplify this, 4 times 1/9 is what? 4/9 plus 9 out of 9. That's 0.5 times 2 is 9. And then I have 5 out of 9. I got 13 out of what? 9 plus 7 times 2, that's 14 out of what? 9. 9 times 1/9 is what? 9 out of 9. So if you simplify that, that is going to be 54 divided by 9. And that is equal to what? Is equal to 6. So then what is the population median? Now remember our population is what? 4, 5, and 9. Now what is the median of these numbers? It's the middle. The middle is what? It's 5. So the population what median is what? 5. So as you can see, the 5, the population median, is not equal to what? The mean of the sample median, which we got was 6. And therefore, what we say is that the mean, also the sample median, okay, doesn't target the what? The population median. Therefore, it is what? It is biased. What is biased? The what? The sample median is biased, estimated. Okay. So again, we'll do this example in class. Okay. Then the last one I want to do is the population, the sample mean. Now this is going to come back again because in the next section that talks about central limit theorem, we'll be using this a lot, the sample mean. And as we mentioned earlier on, sample mean is what? Is an unbiased estimator of the population mean. So again, I'm going to use the author with the 3 children with the ages 4, 5, and 9. And then this time I'm going to find the mean instead of either the range or the median. But note that if I have 2 numbers, finding the middle is the same as finding the mean or the average. So basically what we just did, okay, this example we just defining this, what we have is the probability distribution, okay, will be the same for the median as same as the probability distribution for the mean or the sample mean. Okay, so but it's something we need to, what's the behavior of the sample mean? The distribution of this sample means tend to be a normal distribution. Okay, as we can see from this diagram, it's a normal distribution. And the sample mean, it targets the value of the population. Therefore, it is what? An unbiased estimator. Okay. And we'll be using this concept in what? In the next section. That is 7.6 to 6.4. Okay, 6.4. We're using that a lot. Okay, so now let me use the same to calculate, okay, the mean, and to demonstrate that the sample mean is an unbiased estimate. Okay, all right, so now the samples will be the same. Don't forget that. I think let me go to the next slide, actually. Okay. Now we have population. Our population is this. Yes. Our population, it has the student, the 3 children with the ages 5, 4, and then what? And 9. Okay. Now let's find our probability distribution. Like I said, this is the same as what? So our sample, and this will be the sample mean. So only different that this heading will be what? Sample mean. So we have the samples will be the same, 4 and 4, 4, 5, 4, 9, 4, 5, 4, 5, 5, 5, 9, 9, 4, 9, 5, and 9, 9. Then what's the mean? What's the average of this? The same 4. The average of 4 and 5 will be 4.5. 4 and 9 will be what? 6.5. 5, 4 and 5 and 4 will be 4.5. 5 and 5 will be 5. That will be 7. This will be 6.5. This will be 7. And that will be what? That will be 9. So what is the probabilities? Okay. So let's have our probability distribution here. This is our probability distribution of what? The sample means. So I'm going to put my probabilities here, and then I have my sample means. You can call it the S bar. So this variable has the values what? 4, 4.5, 5, 6.5, 7, and 9. The probabilities are 1/9, 2/9 for 4.5. 5 is 1/9, 6.5 is 2/9, 7 is also 2/9, and then 9 is what? 1/9. Again, when you add all this together, the probabilities usually get what? Usually get what? So let's find the mean of the sample mean. You know the sample means, all right? So this is the expected value, just like we did. So this will be 4 times 1/9 plus 4.5 times 2/9 plus 5 times 1/9 plus 6.5 times 2/9, 7 times 2/9, then plus what? 9 times 1/9. Okay. Now if you calculate everything, you have the same as before. You get 54 over what? Over 9, and that is what? 6. So then let's find our population what? Population mean. Now usually we use this symbol as a mean, like that. Okay. Now our population, don't forget, our population is what? Population is what? 4, 5, and so what's the mean of that? This is the given by the sum of what? X over capital N. So that is what? 4 plus 5 plus 9 over what? 3. And that gives me 18 over 3. which is also what? Which is also 6. So now you see that the sample, the mean of the sample means is 6. The mean of what? The population, the population mean is also what? 6. So what can you say? You say that the sample mean, okay, the sample mean X bar targets the what? The population what? The population mean. Okay, so the statistic X bar targets what? The parameter mean. And therefore, we say that X bar is an what? Unbiased estimator of what? Of mean. Okay. So far I've demonstrated that the range is biased, the median is also biased, the sample proportion p hat is unbiased, as well as the sample mean is also unbiased. Okay. Now we'll do another example in class this week or tomorrow. So we want to recap and start talking about sample. Why sample with what? Why do we sample with what? With replacement. Okay. Sampling is conducted with replacement. Why? Because of the following two important reasons. When selecting a relatively small samples from a large population, it makes no significant difference whether we sample with replacement or without replacement. Okay, and sampling with replacement results in independent events that are unaffected by previous outcomes. And we know that independent events are easier to analyze and result in similar calculations in formulas. Okay, so that brings us to the end of this section.